A system of equations contains two equations with two unknown variables, in this case, x and y. When solving a system of equations using the substitution method, one variable is solved from either of the two equations. It doesn't matter whether you solve for x or y. Here, y has already been solved in the lower equation, so it's easy to start from there. We substitute that expression for y into the equation above in place of y. Then the upper equation contains only x as its variable, and it can be solved like an ordinary equation. We combine the x terms, move 7 to the right side of the equation, which changes its sign, multiply by -1 to remove the minus sign from in front of x, and then calculate the sum of the numbers on the right side. This gives us x equals 2. Now that we know the value of x, we can substitute it directly into the other equation, the lower one, in place of x, and calculate the value of y. We get y equals 3. The answer is written as x equals 2 and y equals 3. When solving a system of equations, you must always find the values of both variables. It's not enough to solve for just one variable. In the next example, we use the addition method, also known as the elimination method. In the addition method, it's important that both equations are arranged in the correct form. X terms in the first column, y terms in the second, and numbers on the right side of the equals sign. In the addition method, the equations are added column by column, and in this summation, one of the variables should be eliminated entirely. Before performing the column-wise addition, we multiply the upper equation by -2. Let's see why this operation is done. This was done to make the coefficient of x equal to -2, and now when we add column by column, we get 0x from the first column, -y from the second, and -3 from the third. So x is completely eliminated, and we can solve for y. It doesn't matter which variable is eliminated in the column-wise addition, or which variable is solved first. We bring back the original equations, and now the value of y can be substituted into either of the original equations. As a rule of thumb, choose the simpler-looking equation. We substitute y equals 3 into the upper equation in place of y, and solve for x. Thus, we have found two solutions for the system of equations.